Hi guys, let's solve this differential equation. Of course, we have solution. The question is actually looking in form of equation appeared in form of exact differential equation. So we have 2xy dx plus x square minus y square dy equal to 0, where we can compare with m dx plus n dy equal to 0, where m corresponds to 2x pi and n corresponds to x square minus y square. So actually, for us to solve this equation, we first of all solve to determine if the equation is exact before we proceed with the solution. So that's what we are about to do. So, and for us to determine if the equation is exact, we're going to take partial differentiation of m with respect to y, because we have x here with respect to y. Differentiating this guy with respect to y will give us 1, so we have 2x left. And of course, partial differentiation of n with respect to x here. When y is constant, y square is 0, then the differential of x square is actually 2x. Okay, so you find that the equation is actually exact. So we have here partial differentiation of m with respect to y is equal to partial differentiation of n with respect to x is exact. Okay, so let's solve the differential equation now, since we've already confirmed that the equation is exact. So we have there exists a general function that's an implicit function z of x comma y, which is the original function from which this equation is formed. That is what we say initially, that is where the solution lies. So there exists a function z having a function z of x comma y such that partial differentiation of z with respect to x is equal to m. Then by integrating both sides, we have the function integral of the z will give us z. So we have that particular function z of x comma y to be equal to the integral of m dx. Of course, integrating both sides here. Of course, the constant after integration is c of y, because the integral is with respect to x, keeping y constant. So the constants will be a function of y, like we've been saying before. So we have z to be equal to integral of m. And what m are we talking about here? M is equal to 2xy. We have m 2xy with respect to x plus c of y. Okay? So z is equal to the integral of 2xy with respect to x. Then x, differentiating x here is 1. I'm sorry, we're talking about integration here. So integrating 2xy with respect to x alone will give us 2x squared y, bring down the power over 2 plus c of y. Okay, so take away this, we have z is equal to x squared y plus c of y. Alright, so now we're going to find the value of what? C of y. We don't know what c of y is. We don't know what c of y is actually. So we're going to have there exists also a function such that partial differentiation of z with respect to y in this case is equal to n. So visually we'll have our integration of the first one with respect to x, then secondly we differentiate the function we got with respect to y to be able to evaluate c of y and then substitute it back here. So what we are doing now is partial differentiation of this value, this particular function with respect to y, and whatever thing we get, we'll relate it with what? N. Alright? so that we have the partial differentiation with respect to y of z, and of course the z is equal to x square y plus c of y equal to n. Of course, our n is equal to the value I have for n. Of course, our n is equal to is equal to x square minus y square d x square minus y square. That's our n. N is equal to x square minus y square. Okay? So we have the partial differentiation with respect to y here. With respect to y here will give us x squared. Because differentiating y is 1, we have x squared plus. Coming to this side, differentiating c of y, c prime of y equal to x squared minus y squared, which is the value of n. Okay? So now, we make c prime of y the subject of the formula. We're taking out x squared from both sides. We have c prime of y to be equal to minus y squared, right? Then integrating both sides, we have integral of c prime of y is equal to negative integral of y squared dy with respect to y. So integrating c prime of y, c of y equal to the negative y cubed over 3 plus k. Okay? Then this is the value of c of y. Then we have to substitute here because c of y is what we're looking for. We found it here. Therefore, z is equal to x square y plus c of y. And of course, c of y is minus y cubed over 3 plus k. So take k to this side, we have z minus k is equal to x square y minus y cubed over 3. And of course, a is equal to x square y minus y cubed over 3, where z minus k is equal to a. And eventually, this becomes the final answer. That's the solution to the differential equation. Thank you and have a wonderful day. In my next video, we're going to talk about non-exact equations, non-exact differential equation. That is the how to find the method of finding the integrating factor.